Now let us study the different properties of definite integrals. The use of these properties is that it simplifies the evaluation of many definite integrals, so therefore we have to specifically use them wherever applicable. Now the first property, as it's shown here, says that integral of f of x from a to b is equal to integral of f of t from a to b. So what it essentially tells is that the value of the definite integral does not depend on which variable we use. So whether it is x or t or it might be anything else, the answer will be the same. Now the reason that this is the case is because, suppose, let us consider that the integral of f of x is g of x. Right? So when we evaluate it between the limits a to b, we know that this is given by g of b minus g of a, because we have to substitute upper limit and lower limit and then subtract. Now if instead of x, if we use the variable t, in that case the integral will be g of t, but since we have to evaluate that anyways between the upper limit and lower limit, on substitution we still get g of b minus g of a. So you see, the final answer is one and the same thing irrespective of which variable we use in the original integral, provided the limits are same. So that is the first property. Let's see the next property. Now here integral of f of x from a to b is equal to minus the integral of f of x from b to a. So here the change on two sides is that the limits are interchanged, that is the upper limit and lower limit are exchanged. So if that is the case, then the integral becomes negative of the original. So this is also very much straightforward, because we know that, suppose, let us denote the integral of f of x as g of x. So when we evaluate it between a and b, we get it as g of b minus g of a. Right? Now the same if we calculate on the right hand side, the minus of integral g of x, but now this is evaluated from b to a, so that gives us minus of integral of g of a minus g of b. So if we open the bracket and bring the minus sign in, we ultimately get g of b minus g of a, so which is nothing but same as what we got on left hand side. So if the limits are interchanged, then the value of a definite integral changes the sign. This is what this property says. Now moving on, we have the third property. Now here the integral is taken from limits a to b, then that can be broken down into two integrals, in which the limits are from a to c in the first integral, and in the second it is from c to b, where c could be any number lying between a and b. Now to see this particular property, we can take help of the diagram. Suppose this is a function and say this is a and this is b, and we have somewhere in between them a value c. Now to integrate from a to b means we are trying to calculate the area under the curve between a to b, and since it's clear that the total area is equal to this specific area on the left hand side, that is from a to c, plus the remaining area on the right hand side, that is from c to b. So therefore the property has been proven. Or in other words, if you want, the right hand side integral can be written as g of c minus g of a after putting the limits, plus for the second one it is g of b minus g of c. So here what happens is g of c gets cancelled and we are left with nothing but g of b minus g of a, which is precisely the integral on left hand side. So therefore we have this particular property. Let's go ahead and see the fourth property. Now here the integral is taken from a to b of a function f of x. Then it is same as the integral taken from a to b, but now here the function is of the variable a plus b minus x. So what it means is when x is replaced with lower limit plus upper limit minus the variable, then the value of the definite integral remains same. Now to prove this, we start from the right hand side and use the substitution. Okay. So let this particular big expression be substituted with a new variable, say t. Right. So therefore if you differentiate, we get minus dx is equal to dt. So therefore dx is equal to minus dt. Now as we have seen earlier, when we use the substitution, we have to change the limits also. So therefore when the original variable x was equal to the lower limit a, we have to find out what will be the value of t. So in that case we have a plus b minus a is equal to t. So cancelling a, we get t equal to b. Similarly, when x was equal to the upper limit b, so in that case we had a plus b minus b is equal to t. Correct? So on cancelling b, we get t is equal to a. So therefore our right hand side integral now becomes, if you now see the limits get interchanged, that is now the new limits are from b to a, f of the expression has been replaced with t and dx is equal to minus dt, so that is minus of dt. So if you take minus sign outside, we have integral of b to a f of t dt. Now if we want to remove the minus sign, we will have to switch the limit, so that is from a to b we have f of t dt. And as we have seen in the first property, the integral remains the same even if we change the variable. So instead of t, we can write it as x also, won't change the value, and this is precisely the left hand side. Right? So the idea is to substitute the expression and prove the property. Now as a corollary of this, if the lower limit is already 0, then what we will be left with is just the upper limit minus x. So that's what, let us see on the next slide. That is, the corollary is that if the lower limit on left hand side integral is 0, then on the right hand side the expression will be just a minus x, because it is actually equal to lower limit plus upper limit minus x, which is nothing but a minus x. So it is just a modified form of the original result that we saw. Let's go ahead to the next property. Now here see the pattern, that is on left hand side we have the integral from the limit 0 to 2a of the function f of x, then that is equal to integral of f of x from 0 to a plus integral of f of 2a minus x from 0 to a. Right. So if you see on the right hand side, in both the integrals the limits are same, which are 0 to a. So a is nothing but half of the value of the upper limit on the left hand side. So that is to be kept in mind. Now how do we prove this? So in the first we have f of x and in the second we have f of 2a minus x. Now what do we do to prove this is that we start off with the second integral on the right hand side. Okay, and we use the substitution, that is, let us put 2a minus x is equal to t So that clearly gives us dx is equal to minus dt. Now when x is the lower limit, that is 0, here we have t is equal to 2a, because if you put x as 0 you will get t is equal to 2a. And when x is a, we have t is equal to 2a minus a, that is nothing but a, right? So therefore let us write the first integral on the right hand side as it is, that is 0 to a f of x dx plus, now for the second integral the limits are from 2a to a f of t, and here we have minus dt. So that is equal to 0 to a f of x dx. Now suppose we want to remove this minus sign, then we will have to interchange the limits, correct? So therefore we have minus of, okay, I will change the minus sign and we will write the reverse limits, that is a to 2a, because we have removed the minus sign. And now in place of t we can change the variable and write x so that it won't change the value. So yeah, we get f of x dx. And now if you observe, the first limit is from 0 to a and the second limit is from a to 2a. So using the property that we have already seen, we can merge this into a single limit from 0 to 2a of f of x dx, which is nothing but the left hand side. So in this way we have proven this property. Now let's go ahead to the last property that we need to study for the definite integrals. It says that the integral of the form where the limits are from minus a to a. So this is what we should remember. The limits are the negatives of each other, so that is from minus a to a f of x dx is given by either of the two values as shown here. Now it depends on whether the function f of x is an even function or odd function. If f of x is even function, then the value of the integral on left hand side will be 2 times the integral of f of x from 0 to a. On the other hand, if f of x is an odd function, then the value of that integral is straight away 0, right? So let us see how to prove this particular property. Now for that, let us start off with the left hand side. This we can break as minus a to 0 f of x plus 0 to a f of x, correct? Because 0 lies between minus a to a. Now in the first integral we will substitute the variable, that is in place of x I will write minus t, right? So that gives us dx is equal to minus dt. When x is minus a, that gives us t is equal to a, and when x is 0, that gives us t is equal to 0. So therefore on substitution we get the new limits are from a to 0 f of minus t into dx is nothing but minus dt plus 0 to a f of x dx, that is equal to. Now if we want to remove the minus sign, we need to interchange the limits. So after removing the minus sign, we will write the limits as 0 to a, and here I have f of minus t dt plus here we have f of x dx integrated from 0 to a. Lastly, we are free to change the variable, that is instead of t I can very well write x, so that is f of minus x dx plus 0 to a f of x dx. Now at this point let us see how the type of function will give us the further result. If we consider f of x is an even function, then f of minus x will be same as f of x, so therefore we can add the two integrals which I have got at the end, and therefore we will get the result as 2 times the integral from 0 to a, right? On the other hand, if f of x is an odd function, then f of minus x will be negative of f of x, so therefore these two integrals which we have got at the end will cancel each other, and hence we will get the result as 0, right? So therefore we have these particular expressions. The importance of this property is that if we get the definite integral of the form minus a to a, and if we happen to see that f of x is an odd function, then straight away we can write it as 0, so that saves a lot of time. So let us recap all these properties once again. First property is integral of f of x from a to b is same as integral of f of t from a to b, that is change of variable does not change the value of the integral provided the limits are same. Second says that if we interchange the limits, then the value of the integral becomes negative of the original value. In the third property we have seen that a definite integral can be broken into sum of two definite integrals considering a value that lies between the two limits. Okay. And next property, fourth property is integral of f of x from a to b is equal to integral of f of a plus b minus x from a to b, and that gives us a special case or a corollary that integral of f of x from 0 to a is equal to integral of f of a minus x from 0 to a. In the fifth property we saw that integral of f of x from 0 to 2a can be written down as a sum of two integrals, in which the first is integral of f of x from 0 to a and the second is integral of f of 2a minus x from 0 to a. And in the last property, integral of f of x from minus a to a, so we have to remember these limits, this pattern of limits properly, then this is equal to one of the two values. If f of x is an even function, then the answer will be 2 times integral of f of x from 0 to a, or if f of x is an odd function, then the answer will be 0. So using these properties, now we will see how to solve the different examples.